All right, here we're looking at factoring, and factoring really at its core is really just the reverse operation of our distributive property. All right, so when you think about our distributive property, if we have a number being multiplied on the outside of the parentheses, what we do is we multiply it by everything inside the parentheses. So we're multiplying it into something, and then factoring is just the reverse of that. We're dividing that thing back out. All right, so distributing is multiplying in, factoring is dividing out. So it's kind of these reverse processes where we're just trying to undo what we did with our distributive property. Okay, that's what factoring is. All right, the first way we look at for factoring is just factoring out the greatest common factor, or the GCF. And remember, the greatest common factor is just the largest thing that divides evenly into everything that we're looking at, okay? Into each of the terms that we have, all right? And so when we're talking about numbers, it's the largest number that divides evenly in there. When we're talking about variables, it's the largest variable that we can divide out as well, okay? So for example, when I look at this first one, here I've got a 2x to the 5th plus 6x. If I want to factor out the greatest common factor, between the 2 and the 6, the largest number I can divide out is a 2, so I write the 2 down. Between an x to the 5th and an x to the 1st, really I'm trying to divide out the most x's I can. And so if I have 5 x's with the first one and 1 x with the second term, the most x's I can take out of both would be 1 of those x's. So I'm going to take out an x to the 1st. And now what I'm going to do is I'm going to set up my parentheses. So again, it's just the reverse of the distributive property. Instead of multiplying this thing in, we're now dividing it out. So we're putting it on the outside of parentheses. And now I just divide it out of each of these. So I take this first term, the 2x to the 5th, and I divide it by the 2x. And when I do that, 2 divided by 2 is 1. X to the 5th divided by x to the 1st, I subtract the exponent. It's going to leave me with an x to the 4th. Okay? And then I do the same thing with the second term. I take the 6x and I divide it by the 2x. And when I do that, the 6 divided by 2 is a 3. And the x divided by x is an x to the 0, which is just 1, so I don't need to write that. So I'm just left with this inside my parentheses. So this is my factored form when I factor out the greatest common factor. When I look at this next one, again, I'm factoring out the greatest common factor, so I'm looking for the largest thing that divides evenly into each of these. And so as I look at the numbers, the largest number that I can divide out evenly is a 3. When I look at an x squared, an x to the 4th, and x to the 6th, the most x's I could take out of all three of these would be an x to the 2nd, because they each have at least 2. And now I'm just going to divide that thing out. So the 9x squared divided by the 3x squared is going to leave me with a 3. The negative 3x to the 4th divided by the 3x squared is going to leave me with a minus 1x to the 2nd. Again, the rule here is we divide the coefficients, we subtract the exponents. And now the 12x to the 6th divided by the 3x squared is going to leave me with a plus 4x to the 4th. Okay? And then the last thing we might do with this is, as we look at that trinomial that's inside the parentheses, I'm just going to go ahead and rewrite that in descending order, because this is kind of an awkward way to have this written. So I'm going to write it as the 4x to the 4th minus the x squared plus 3. And that's the way I'm going to leave this thing. If I look at the next one, the greatest common factor between a 3x and a 7y, well, really there's nothing that I can really take out here, but keep in mind that I can always divide out of 1, so the greatest common factor is 1, and if I divide that out, it leaves me with a 3x plus 7y. But of course, I would never write it this way. Because it's only divisible by 1, what I say is that this one is actually prime. And that makes sense because when you think about prime numbers are numbers that are only divisible by 1 in themselves. And that's what's happening here. It breaks up into a multiplication of 1 times itself. So it's a kind of a prime factor. It's important, though, to understand that you can still factor a 1 out. All right? Because there are situations where even if it's just a 1, we'll have to factor something out. And we'll see that momentarily. If I look at this next one, again, the greatest common factor here as I look through between the numbers is going to be a 2. And then because that minus 4 doesn't have an x, that's it. I can just factor a 2 out. That leaves me with an x squared plus 3x minus 2. And that's really all I can do for this one. This one doesn't factor any further. Okay? Next, we're going to look at factoring by grouping. And factoring by grouping, basically what we do is we put the terms in groups, all right? And typically, we're going to put them in groups of 2. So I'm going to put them in groups, and I just use parentheses to do that. I just kind of section them off. Again, typically, this is groups of 2, all right? So we'll make a note to self. There are certain situations where you want to do groups of more than 2, maybe 3 or 4 or whatever. But for our purposes, most of the time, we're going to be doing groups of 2 here. Okay, so keep that in mind. And we just use parentheses to section them off. Then what we do is we factor the greatest common factor out of each group. We basically look at each set of parentheses and we do what we did on the previous page. We just factor out the greatest common factor. This is just like the problems we just did, but we're going to have more than one problem to do within the context of each of these examples. Okay? After we're done factoring the greatest common factor of each, then we look for common polynomials. In other words, we just scan this thing and look for big chunks that are exactly the same, and then I'm going to factor out those big chunks as well. All right? So here's what this looks like. As I look at this first example, here I've got 4 terms. I'm going to put them in groups. So I'm going to put them in groups of 2. So I'm going to group the first 2 together and group the second 2 together. And notice right here, when I group these second 2 together, where that plus sign goes, the signs that are in front of these things kind of are attached to this number, and they tell us whether the number is positive or negative. So make sure you include the sign in there with the term, okay? So this way we know if it's positive or negative, because that's really going to help us when we go to factor these things, all right? So now if I ignored this second group, if I just ignored this guy for a second and just looked at the 3n to the third minus 12n squared, if I told you to factor that binomial, we would just factor out the greatest common factor. The greatest common factor here is a 3n squared. And when I divide that out, it leaves me with an n minus 4. And now what I'm going to do is I'm going to say, okay, let's look at this second group, and I'm actually going to ignore the first group. So if I were to ignore this first group and just look at the second binomial, 2n minus 8, I'm going to factor out the greatest common factor. Here it's a positive 2. And again, just like we included the sign inside those parentheses, I've got to include a sign here to tell me if this is positive or negative. So since I'm factoring out a positive 2, I'm going to put a plus 2. All right? And when I divide that out, it leaves me with an n minus 4. So now, as I look at this thing, now I'm going to scan across for big chunks that are exactly the same. And we see one big chunk that's exactly the same, this n minus 4 right here. Okay, so I've got this big chunk that's exactly the same. So what I do is I kind of factor out that big chunk. I take it from these 2 locations and I rewrite it over here at one location. So basically I factor out this n minus 4. So I write the n minus 4 down on the outside. And if I were to divide out that n minus 4 out of each of those big chunks, in other words, if I were to take the n minus 4 out of this piece and take it out of this piece, you can see that I'm left with the 3n squared and a plus 2. Well, that's my other factor. All right, so if I were to take out that big chunk, it leaves me with a 3n squared plus 2. All right, and really what you should see here is this is the reverse of our distributive property. Okay, this is what we do when we FOIL these things. If I were to take this thing, let me rewrite it this way. Think about what the process is that we're showing here in reverse. I'm writing m's instead of n's. I know my letters. So what happens here is if I were to FOIL or distribute, I would distribute this guy, which would be like me doing 3n squared times the n minus 4. I'm going to distribute it to that. And then I would distribute the 2. That would be like me doing the plus 2 distributed to the n minus 4. And then I would actually do the distribution. And it would leave me with a 3n cubed minus 12n squared plus 2n minus 8. And so you can see literally these reverse processes right here. If you look at step 1 here, matches step 3 down here. Okay, and step 2 matches this middle step. And so this last step matches this step. All right, it's literally the reverse of us doing our distributive property or FOILing. Okay, that's what factoring by grouping is. It's us undoing multiplying out 2 binomials. Okay, so the factored form of this thing is right here. And the other thing that this tells us is that we can easily check these answers by just multiplying it back out and see if we get to the original answer. Okay. If I take a look at the next one, if I approach this the same way, again, I'm going to group these. So I group the first 2 together, group the second 2 together. Out of the first 2, I can factor out a 4x cubed. So that leaves me with an x minus 2. Out of the second group, it looks like I can factor out a positive 12x, so I write a plus 12x. Again, that leaves me with an x minus 2. And now I can see these 2 big chunks that are exactly the same. So I'm going to factor out the big chunk, and it doesn't matter what order we write this in. If we write the x minus 2 second, and then we write what was going to be left, the 4x cubed plus 12x, that's fine as well. All right, so just keep in mind, we can write this in any order. However, there's an issue with this final answer. I can't leave this thing this way. All right, and the reason for that, as we look at this first binomial, the issue is right here with this first guy. that first binomial still has a greatest common factor left in it, so I have to factor out that greatest common factor. It has a greatest common factor of 4x. So I have to factor out that 4x, which leaves me with an x squared plus 3. And then this second binomial is kind of just tagging along for the ride. It remains unchanged. This is my final answer. So again, you have to factor out everything completely, which means you can't leave any greatest common factors lying around. And when you look at the original problem, the thing that's interesting about this original problem, when you look at each of these terms, they all have a greatest common factor of 4x. So what that tells us is that there's another way we can actually approach this problem. I could factor out the greatest common factor first. And here's what that would look like. If I start by factoring out the 4x out of each of these, that's going to leave me with an x cubed minus 2x squared plus 3x and a minus 6. Okay? And now look at what's in the parentheses. Now we're going to do factoring by grouping with what's left. So I'm going to group these two together, and I'm going to group these two together. This 4x is just going to kind of tag along for the ride this entire time. Out of this first group, I can factor out an x squared, which leaves me with an x minus 2. Out of the second group, we can factor out a 3, which leaves me with an x minus 2. And so now what we see here, again, this 4x just kind of tags along for the ride. Inside here, I can see my two factors. The x minus 2 is one of them. And the other factor is right here, the x squared plus 3. All right? So it's really up to you whether you want to factor the greatest common factor out first or wait till the end. In my opinion, it's always better to look for it first because that'll lead us to some shortcuts down the road. Okay? So always look for the greatest common factor first, and then look for it again at the end to double check your answer. All right? But you can see we get the same thing either way. Okay? If I look at this one, again, I scan across. There's no greatest common factors between any of these, so now I group them. I group the first two together. I group the second two together. And out of the first two, I can factor out a 3x squared. That's going to leave me with an x plus 3. Out of the second group, you have to factor something out, whether it's a 1 or a negative 1. In this case, it's going to be a negative 1. So I'm going to factor out a negative 1, which leaves me with an x plus 3. And really, anytime I see a negative in front of this first term in the second binomial, I'm going to factor out a negative. Typically makes things easier. And so for this one, I factor out that negative, and you can see right away that it gives me that same binomial in my parentheses. If I factor out and I don't get the same binomial, I can't do anything else. So I kind of want to get the same binomial if I can. All right? And so for this case, I had to factor out a negative. And so now my two factors, I can see them. It's the x plus 3 as one of them. And then if I were to take away that x plus 3, I'd be left with an 3x squared minus 1. Okay? And that's factoring by grouping.